Hello students, welcome to Diksha Karnataka YouTube channel. In this video, I'm going to discuss solution of the COMEDK 2022 physics question paper. Okay, question number 31 to 60. If you haven't downloaded the question paper, please join the WhatsApp channel using the link which is given in the description box. In there, you will get the question paper and detailed solution. Yeah, so let us start. Question number 31. A water is poured in a tank through a cylindrical tube of area of cross section A and the ejecting water at a constant speed 4 meter per second. That is, velocity of efflux is 4 meter per second. The tank contains a hole of area A by 2 at a bottom. Level of water in the tank will not go up beyond. Okay, so here apply equation of continuity, right? A1 V1 is equal to A2 V2, right? A1 is A, V1 is 4 meter per second, and A2 is A by 2, and V2 is root of 2gh, Here A will get cancelled, right? So now 2 into 4 is 8, right? So 2gh is equal to 8 square, that is 64, right? So now h equal to 64 divided by 20. Okay, 64 divided by 20. So now solve this, you will get 3.2 meter. So the correct option is C. Okay, yeah. Next question, question number 32. If R and C denote the resistance and capacitance of a material, then the dimension of CR will be. The direct question, right? So we know that charging and discharging of the capacitor, right, in RC circuit. So the charging of the capacitor Q equal to Q naught into at any time t, the charge on the capacitor is Q equal to Q naught into 1 minus e to the power minus t by RC. So what is RC? Time constant, right? Isn't it? So RC is time constant, isn't it? So the dimension of RC must be equal to the dimension of the T, right? So the correct option is B. Okay, yeah. Next question, question number 33. An ideal gas is taken through the cycle ABCA as shown in the figure. If the net heat supplied to the gas in the cycle is 5 joule, the work done by the gas in the process C to A is, that is, we need to find work done by the gas in the process C to A, right? Okay, so let us find the work done by the gas. Okay, heat supplied, delta Q is equal to delta U plus delta W, right? Delta Q equal to delta U plus delta W. So this is the cyclic process, right? Isn't it? So the change in internal energy is 0, right? So now delta Q is equal to delta W, right? Delta Q equal to delta W. Okay, so now let us find delta W. Okay, that is work done by the gas from A to B, B to C, C to A. So now delta Q is equal to work done by the gas from A to B, B to C, C to A, right? C to A. We need to find WCA, right? So what is the work done by the gas from A to B? So that will be 10 joule, right? So pressure is 10, volume is change in volume is 1 meter cube, right? This is meter cube. Okay, so here from A to B, the work done is 10 joule. Okay, from B to C, work done is 0, right? So C to A we need to find. Heat supplied is 5 joule. So 5 equal to 10 plus 0 plus W C to A. So now W C to A is equal to minus 5 joule. So the correct option is A. Okay, yeah. Next question, question number 34. From a circular disc of radius r, a square is cut out with a radius as its diagonal. Okay, so this is the circular disc, right? So this is the center of the disc, right? So now square is cut out, right? Now diagonal of the square is equal to radius of this circular disc, right? The center of mass of remaining portion is at a distance from the center. Okay, so now we need to find the center of mass of the remaining portion, right? So we know that center of mass of the circular disc lies at the uniform disc. Okay, center of mass of the uniform circular disc lies at the geometric center of this disc, right? Okay, so when you cut out the square portion, right, this portion, what happens? Circular center of mass will shift, right? Center of mass will shift towards left. Why? Because here left side the mass is more, right? We know that center of mass lies on the heavier side of the side of the object, right? Isn't it? Okay, so now this is r, right? So now this will be r by 2 and r by 2. Now this is r by 2, r by 2 and r by 2. So what is the side of this square? The side of the square will be r by root 2, r by root 2, right? So now the center of mass of the remaining portion, right? Center of mass of the remaining portion, okay, RCOM is equal to anyway center of mass lies along the x-axis, okay, lies along the x-axis or the horizontal line, okay. So center of mass of the remaining portion is equal to mass of the disc, okay, mass of the disc into here this point is, take this point as the origin, okay. So now here this is 0, 0, right? So mass of the disc into 0 plus mass of the removed portion, okay, that is mass of the square. So I am going to take negative mass because we have removed the mass, right? So negative mass of the square into here the center of mass of this square will be r by 2, right? R by 2 from the center of the disc. So this will be r by 2, right? Whole divided by mass of the disc minus mass of the square. Okay, now we need to find mass of the square, right? Mass of the disc we know, that is sigma into pi r square, mass of the disc, right? MD. Sigma is surface density, right? Surface density. What is surface density? Mass per unit area, right? So disc is constant, so sigma of disc is same as sigma of square, right? Sigma of disc is equal to sigma of square. So sigma of disc is MD divided by pi r square equal to sigma of S is mass of the square divided by area of the square, so that will be r square by 2, right? Here r square will get cancelled, right? So now mass of the square is equal to, or mass of the square plane or square lamina is equal to MD divided by 2 pi, MD divided by 2 pi. So now RCOM is equal to, here this will be 0 minus MS is here MD divided by 2 pi, right? MD divided by 2 pi into R by 2 whole divided by MD minus MD divided by 2 pi. Okay, so now solve this, you will get R divided by 4 pi minus 2. Okay, and center of mass shift towards left, Okay, so the correct option is A. Next question, question number 35. A bar magnet of length 6 centimeter is placed in the magnetic meridian with N pole, that is north pole, pointing towards the geographical north. Okay, north pole of the bar magnet pointing towards geographical north. Okay, two neutral points separated by a distance of 8 centimeter are obtained on the equatorial axis of the bar magnet. So here we got two neutral point. The distance between the two neutral points is 8 centimeter. So the distance between the bar magnet and the neutral point, any one neutral point, is 4 centimeter. The length of the bar magnet is 6 centimeter, right? L equal to 6 centimeter. Sorry, 2L equal to 6 centimeter. 2L equal to 6 centimeter. So L equal to 3 centimeter. Okay, yeah. If BH, that is horizontal magnetic field, okay, horizontal Earth's magnetic field is equal to 1.2 into 10 to the power minus 5 Tesla, then the pole strength of the magnet. So we need to find small m, right? Pole strength of the magnet. Okay, so now here we know that here B equal to BH, right? Here B equal to BH, so B equal to mu naught divided by 4 pi into m divided by r square plus L square to the power 3 by 2. Okay, r square plus L square to the power 3 by 2. So B equal to mu naught divided by 4 pi m divided by r square plus L square to the power 3 by 2. So m, that is magnetic moment, is equal to the pole strength into 2L, right? Pole strength into 2L. So now B equal to here mu naught divided by 4 pi into m into 2L divided by r square plus L square to the power 3 by 2. Okay, so what we need to find here? We need to find the pole strength, right? So now m equal to here B into 4 pi divided by mu naught into here r square plus L square to the power 3 by 2 whole divided by 2L. So now what is R? R is 4 centimeter. Okay, L is 3 centimeter, and mu naught by 4 pi is 10 to the power minus 7, right? So 10 to the power minus 7, what is the SI unit? The 10 to the power minus 7 Tesla, right? Tesla, and then mu naught I divided by r square, right? Okay, mu naught I divided by r square, Tesla, here meter square per ampere. Okay, Tesla meter square per ampere. So now here we know the value of mu naught by 4 pi, right? And then we know the value of B, that is 1.2 into 10 to the power minus 5 Tesla, right? And then we know the value of R, L and so on, right? Okay, R and L. So now solve this. Okay, so now solve this, you will get m equal to 0.25 ampere meter square. So the correct option is B. Okay, yeah. Next question, question number 36. A force F is applied on the wire of radius R and length L, and change in the length of the wire is L. Okay, so change in the length of the wire is L, right? That is dl is equal to L. If the same force F is applied on the wire, if the same material and the radius 4R and the length 4L, right? Okay, here the original length is L, right? So now here the length is 4L and the radius is 4R, right? Length is 4L. Then change in length of the other wire is. So we need to find the change in length of the other wire. Let's say delta L dash. Okay. So here the applied force is same, right? And material of the wire is also same. So Young's modulus of the both wire is same, right? We know that Young's modulus y equal to F into L divided by A into delta L. A into delta L, right? So both have the same material, right? Both wire is made up of same material. So y1 is equal to y2. Okay. So y1 equal to y2. So this will be equal to here f1 into L, f1 into L divided by area. Area is here pi into r square. Area of the first wire pi into r square into delta L, which is equal to f2 into length of the second wire is 4L divided by area of the second wire is pi into 4r whole square, that is 16 r square into delta L dash. So f1 equal to f2, okay, and L will get cancelled, right? And then pi r square will get cancelled, right? So now 4 4s are 16, right? So now delta L dash is equal to delta L divided by 4. Delta L is L, right? So delta L dash is equal to L divided by 4. So the correct option is A, right? Okay, next question, question number 37. A 30 milliwatt laser beam has a cross-sectional area of 15 millimeter square. The magnitude of the maximum electric field in this electromagnetic wave is given by. Okay, we need to find maximum magnitude of the maximum electric field, okay, of this electromagnetic wave, in this electromagnetic wave. Okay, so we know that intensity of the electromagnetic wave I equal to half NC epsilon naught into E square. So what is N? Refractive index of the medium. So here the medium is air, so N equal to 1, right? N equal to 1, isn't it? And we also know that intensity I equal to power per unit area, right? Power per unit area, isn't it? Okay, so now here I is half C epsilon naught A square, okay, half C epsilon naught A square, which is equal to P divided by A. So we need, sorry, half C epsilon naught E square, not A square. Okay, so we need to find E, right? So now E is equal to root of 2P whole divided by 2P divided by C epsilon naught A, okay, C epsilon naught A. So we know the value of P, that is 30 milliwatt, right? And then here we know the epsilon naught, we know the value of C, and we know the value of A, right? So now substitute all the values. You will get this as 1.22 kilovolt per meter. 1.22 kilovolt per meter. Okay, so the correct option is A. Next question, question number 38. The average kinetic energy of the molecule in air at room temperature of 20 degrees Celsius. Okay, so now here we know that average kinetic energy of the molecule in a room at a room temperature 20 degrees Celsius, right? We know the expression of the average kinetic energy of the molecule, that is 3/2 kT, right? So now 3/2 into kB, right? K is Boltzmann constant, okay? So now the Boltzmann constant is 1.38 into 10 to the power minus 23, right? So 1.38 into 10 to the power minus 23, and then T is 293 Kelvin. Okay, 293 Kelvin. So now solve this. You will get 6.07. Okay, 6.07 into 10 to the power. This is 21, right? Okay, 10 to the power minus 21 joule. This is the average kinetic energy. Okay, so the correct option is C. Okay, yeah. Next question number 39. Two guns P and Q can fire bullets at a speed of 2 km per second and 4 km per second respectively from a point on the horizontal ground. They are fired in all possible directions. The ratio of the maximum or areas covered by the bullets by the two guns on the grounds. Okay, we need to find the ratio of the maximum area, right? Maximum areas covered by the bullets fired by the two guns. Okay, so they are asking ratio of the maximum area, right? Okay, so this one is a little bit tougher question. Okay, so first we need to find the area of that path, right? Isn't it? So this is the trajectory of the projectile. We need to find area of this projectile, isn't it? So how to find area of the projectile? So this is the velocity v, right? So here it covers, so this is the point x comma y. Okay, so now it covers the distance x plus dx. X plus dx. Okay, and the height is very small. Okay, so this will be x plus dx comma y, right? So here I can write the function as integration of y into dx, right? Y into dx. So we know that x equal to, that is horizontal distance traveled by the projectile, is equal to v cos theta, right? V cos theta, theta is the angle of projection. Okay, v cos theta into t, and then vertical distance traveled by the projectile is y equal to ut minus half. Okay, so this will be u sin theta. Okay, u sin theta into t, u sin theta into t minus half gt square. Okay, so now what is dx? Differentiate x. Here dx is equal to v cos theta into dt, right? So now substitute here. What is the limit? The limit will be 0 to t, right? 0 to t. T is time of flight, right? So now integration of 0 to t, t is 2u sin theta divided by g. Okay, 2u sin theta divided by g into here y dot dx, right? Y into dx, right? Y is u sin theta, sorry, v sin theta into t minus half gt square into v cos theta into t, v cos theta into dt. Okay, so now integrate this. So this is the area of this line or this trajectory, right? Area under this curve, isn't it? So now solve this. You will get a in terms of theta. Okay, a in terms of theta. Okay, so then differentiate a with respect to t, then differentiate a with respect to t, then equate that into 0. Okay, equate that into 0, then you will get the value of theta. You will get the value of theta. Okay, some value. You will get the value of theta. Okay, then substitute the value of theta to this equation. Okay, substitute the value of theta to this equation. Sorry, not that equation, this equation. Substitute the value of theta to this equation. Okay, then you will get the maximum area. Okay, maximum area, A maximum. So in there, okay, so V to the power 4 term is there. So maximum area is directly proportional to V to the power 4. Okay, V to the power 4. So now here A max 1, take the ratio A max 1 divided by A max 2 is equal to V to the power 4. Okay, V1 to the power 4 divided by V2 to the power 4. So V1 is 2 km per second, V2 is 4 km per second, right? So 2 by 4 is 1 by 2. So 1 by 2 whole to the power 4, right? So this is equal to 1 by 16. So the correct answer is D. Okay, but if you know this result, already, then you can easily solve this question. Otherwise, you have to do all these things. Okay, so I don't know why they asked these kind of question. Yeah. Next question, question number 40. A cell of EMF 2 volt is connected with a load of resistance 1.5 ohm. Okay, so EMF of the cell E equal to 2 volt and the load resistance R is equal to 1.5 volt, 1.5 ohm. The power delivered by the cell to the load is maximum, that is P is maximum, then the power transfer to the load is, okay, we need to find the power transfer to the load, right? So cell has internal resistance, right? So first we need to find the internal resistance, isn't it? So here power P is equal to I square into R, I square into R. I is current in the circuit, right? So current in the circuit, I equal to here E divided by R plus R, right? E divided by R plus R. EMF of the cell divided by R plus R. So now power delivered P equal to E square into R divided by R plus R whole square. Okay. So according to the question, power delivered by the cell to the load is maximum, right? So now differentiate P, okay, differentiate P with respect to R, then equate that into 0. Okay, so then you will get R equal to R. Differentiate P with respect to R, okay, then equate that into 0, then you will get small r equal to capital R, that is internal resistance is equal to external resistance, right? Internal resistance is equal to external resistance. So now we need to find power delivered on the load, right? Power transferred to the load, okay? So P equal to, same expression, P is E square R divided by R plus R whole square, small r equal to capital R from this, right? So now P equal to E square, right? E square is here 2 volt squared, right? So that is 4 volt, right? Into R divided by R plus R is 2R, 2R whole square is 4R square. So 4R square. So R will get cancelled, right? 4 will get cancelled. So now P equal to 1 by R, right? R is 1.5. So 1 divided by 3 by 2. So now P equal to 2 by 3 watt or 0.33 watt. So the correct option is A. Okay. Yeah. Next question. Question number 41. A plain glass mirror of thickness 3 cm of material of mu equal to 3 by 2 is silvered on the black surface. Okay. So let us draw the diagram. So this is the plain glass mirror. The thickness is 3 cm and the refractive index is mu equal to 3 by 2. Okay. When a point object is placed 9 cm from the front surface of the mirror. Okay, point object O. Okay, so it is placed from the front surface of the mirror, right? So this is 9 cm. Then the position of the brightest image from the position of the brightest image from the front surface is, okay, we need to find position of the brightest image from the front surface, that is this surface, right? Okay, so now because of this thickness, right, so the image of this silvered surface will shift, right? So let us find that shift. So now shift of the silvered surface, shift of the silvered surface, right, which is equal to here the thickness of this glass d divided by mu. So now shift is equal to d, that is 3 centimeter divided by mu is 3 by 2. So now 3 will get cancelled, shift equal to 2 centimeter. Okay, shift equal to 2 centimeter, right? Yeah. So now here, then what is the total distance, right? So here if you observe from this point, right, so what is the distance between the silvered surface and the point object? That is 11 centimeter, right? So now the distance between here, distance d between mirror and object O equal to 9 plus 2 centimeter, right? That is equal to 11 centimeter. So we know that according to the plane mirror, distance between the object and the plane mirror is same as distance between the image and the plane mirror, right? So now here the position of the image will be, right, position of the image or image distance, right, image distance I equal to 11 plus 11, that is 22 centimeter. Okay, 11 plus 11, that is 22 centimeter. So what they are asking? They are asking the position of the brightest image from the front surface, this surface, right, isn't it? So here 22, right, 22 minus 9, right, 22 minus 9, here brightest image IB is equal to 22 minus 9. So IB, that is the brightest image, position of the brightest image from the front surface, so that will be equal to 11 centimeter, right? So sorry, 13 centimeter, not 11 centimeter, 13 centimeter. So the correct option is D. Okay, yeah. Next question, question number 42, right? Ultraviolet light of wavelength 99 millimeter, sorry, 99 nanometer. Okay, so this is 99 nanometer, falls on a metal plate of work function 1 electron volt. So phi equal to 1 electron volt. Okay, the wavelength of the ultraviolet light lambda is equal to 99 nanometer. If the mass of the electron is 9.1 into 10 to the power minus 31 kg, the wavelength of the fastest photoelectron emitted is, okay, we need to find the wavelength of the fastest photoelectron, right? Okay, so here apply photoelectric equation. Energy of the incident photon, that is hc by lambda, is equal to maximum kinetic energy of the photoelectron, that is p square divided by 2m, right, p square divided by 2m, isn't it, plus work function of the metal phi, right? So we need to find the lambda, right, lambda of the photoelectron, right? Okay, so now here ultraviolet light of wavelength is 99 nanometer, right? So hc is 1242 divided by 99, here electron volt nanometer, here nanometer, minus phi is 1 electron volt, right, 1 electron volt, so which is equal to p square divided by 2m. Okay, p square divided by 2m. So now here this will be approximately equal to 1.242 electron volt, right? So 1.242 minus 1, 0.242, right? So now P square is equal to, or P, okay? P is equal to here 2 into m. M is mass of the electron, that is 9.1 into 10 to the power minus 31 into here 1242 electron volt nanometer divided by 99 nanometer minus 1 electron volt, okay, 1 electron volt into we have to convert this into joule, right? So then this will be 1.6 into 10 to the power minus 19, okay, into 1.6 into 10 to the power minus 19. You have to multiply. So then take square root, okay. So if we have the expression of P, right, or we have the value of P, then apply de Broglie wavelength, lambda equal to h by P, lambda equal to h by P. So now lambda is equal to h is 6.66 into 10 to the power minus 34 divided by the value of P, okay, the value of P. So solve this, you will get lambda equal to 0.36 nanometer, okay, lambda equal to 0.36 nanometer. Understood? Calculate the value of P, so then you will get the lambda. Apply de Broglie wavelength, then you will get the lambda. So the correct option is D. Yeah. Next one, question number 43. In Young's double slit experiment, the fringe width is found to be 0.4 millimeter. Okay, fringe width beta is found to be 0.4 millimeter. If the whole apparatus is immersed in liquid of refractive index 4 by 3, that is mu W is equal to 4 by 3. Without changing geometrical arrangement, the new fringe width will be, okay, geometrical arrangement will not change, okay, we are not changing the geometrical arrangement. So we have immersed the whole apparatus in a liquid, right, isn't it? Liquid of refractive index 4 by 3. Here refractive index of the water is 4 by 3, right? That's why I wrote mu W. Okay. So now fringe width in water is equal to fringe width in air divided by mu, right? So now fringe width in water BW is equal to fringe width in air, that is 0.4 millimeter, that is 10 to the power minus 3 meter divided by mu 4 by 3. So this will be 0.1, then 0.3. BW is equal to 0.3 into 10 to the power minus 3, right? That is 0.3 millimeter. So the correct option is D. Next one, question number 44. There are two identical containers C1 and C2 containing two identical gases. Okay, gases are identical in the two identical containers, right? C1 and C2. Gas in C1 is reduced to half of its original volume adiabatically. So let us write the adiabatic equation. PV to the power gamma equal to constant, right? So P1 V1 to the power gamma is equal to P2 V2 to the power gamma. V2 equal to V by 2 or V1 by 2. So P into V is equal to here P1 into V. Okay, let's write P1 into V only. P1 into V is equal to P2 into V2 is V by 2 gamma, right? V by 2 gamma. So now here V will get cancelled, right? V will get cancelled. So then P1 is equal to P2 divided by 2 to the power gamma. Okay. While the gas in container C2 is also reduced to half of its initial volume isothermally, right? Half of its initial volume isothermally, that is ideal gas equation P1 V1 equal to P2 V2, right? Okay, P1 dash V1 dash is equal to P2 dash V2 dash. Okay, so now P1 dash into V1 is V, okay, is equal to P2 dash into V2 is V by 2. So V will get cancelled. P1 dash is equal to P2 dash divided by 2. So find the ratio of final pressure in these containers. Okay, we need to find the ratio of the final pressure in these two containers, that is P2 divided by P2 dash we need to find, right? Okay, so now P2 is 2 to the power gamma into P1, right? 2 to the power gamma into P1, right? 2 to the power gamma into P1. So now here P2 dash is 2 into P1 dash. P1 dash is equal to P1, right? P1 dash is equal to P1. So P1 will get cancelled. So now the ratio of the final pressure, right, of this container P2 divided by P2 dash is equal to 2 to the power gamma minus 1 is to 1. Okay. So the correct option is D. Next question, question number 45. If K1, K2 are maximum kinetic energies of photoelectrons emitted when light of wavelength lambda 1 and lambda 2 respectively, the incident metallic surface and lambda 1 equal to 3 lambda 2, then, okay, we need to find the condition, we need to find the relation between K1 and K2. Okay, so let us write the photoelectric equation. Hc by lambda for first case, okay, for first case, Hc by lambda 1 is equal to K1 plus work function phi, right? So Hc by lambda 1 is energy of the incident light, isn't it? Equal to K1 is kinetic energy of the ejected electron or photoelectron, phi is work function. So this is the first equation. So now the second equation, Hc by lambda 2 is equal to K2 plus phi. Work function is same, right? Plus phi. So now here lambda 2 equal to 3 lambda 2, right? Lambda 2 is equal to 3 lambda 2. So now here Hc by 3 lambda 2, right? Hc by 3 lambda 2. Sorry, lambda 1 equal to 3 lambda 2, right? Okay. Here I can rewrite this equation as Hc by 3 lambda 2 is equal to K1 plus phi. Okay, Hc by 3 lambda 2 is equal to K1 plus phi. So now Hc by lambda 2 is K2 plus phi, right? So now substitute the Hc by lambda 2 equation, right? This equation. So now here 1 divided by 3 into K2 plus phi is equal to K1 plus phi. So now take phi to the other side. So K1 is equal to 1 by 3 K2 plus 1 by 3 phi minus phi. So now K1 is equal to K2 divided by 3 minus 2 phi by 3, right? So from this expression, I can conclude that K2 must be greater than or K2 by 3, okay, K2 by 3 must be greater than K1, right? K2 by 3 must be greater than K1. So the correct option is B, right? Here K1 equal to K2 by 3 minus 2 phi divided by 3, right? So K2 by 3 must be greater than K1, right? So then only we will get the positive value, right here. Yeah. Next question, question number 46. A car is moving with the speed of 54 km per hour, right? We have to convert 54 km per hour into meter per second. So 54 into 1000 divided by 3600. So this is initial velocity. So 100 will get cancelled, right? 18 2s are 36, 18 3s are 54, and then 2 5s are. So this will be 15 meter per second. Otherwise, directly multiply 5 divided by 18, right? Okay. If after 3 seconds, the driver applies brakes and it stops. Okay. After 3 seconds, driver applies brakes and it stops, right? Okay, let us find the deceleration of the car, right? After 3 seconds, he applies a brake, right? Isn't it? And then stops. So then 0 equal to your initial velocity is 15 meter per second minus acceleration A, deceleration, okay, minus A is deceleration into time t. Apply first equation of motion, right? T is 3 seconds. So now A equal to 15 divided by 3, which is equal to 5 meter per second square. Okay, deceleration is 5 meter per second square. Then how much distance is covered by the car before coming to rest? Okay, we need to find the distance covered by the car before coming to rest, right? Apply third equation of motion. So V square equal to U square plus 2as, right? So minus 2as, in this case deceleration, right? Minus 2as. So now S is equal to, V is 0 anyway, U square divided by 2 into A. S equal to U square is 15 squared, that is 225 divided by 2 into A, that is 15. So now S equal to, here 15, S equal to, A is, okay, A is 5, right? So 2 into A is 10. Sorry, here this will be 10. 10. So which is equal to 22.5 meter per second square. Okay, so the correct option is A. Next question, question number 47. A source of frequency emits waves at frequency f0. It is moving towards an observer with fixed speed Vs. Okay, it moves with an, it is moving towards an observer with fixed speed is Vs. Okay, yeah, Vs is greater than, sorry, Vs is lesser than V, where V is the speed of the sound, here V is the speed of the sound in air, okay, V is the speed of the sound in air. If the observer, okay, not observers, were to move towards the source with speed V0, one of the following two graphs, A and B, will give the correct variation of the frequency f heard by the observer as V0 is changed. The variation f with V0 is given correctly by, okay, we need to find the correct graph and the slope also, right? Isn't it? So when observer and the source moving towards each other, then apparent frequency heard by the observer, f dash, is equal to f into V plus V0 divided by V minus Vs, right? V plus V0 divided by V minus Vs. So, okay, f0, okay, so this is f0, original frequency. So, option D and A both are eliminated, right? We need to find the correct option between A and B, sorry, B and C. Okay, so now f dash is equal to f0 into V divided by V minus Vs plus f0 into V0 divided by V minus Vs, right? Here f dash is equal to f0 V divided by V minus Vs plus f0 V0 divided by V minus Vs. So we know that the straight line equation y equal to mx plus c, right? Isn't it? Y equal to mx plus c. So here in graph A, V0 representing the x-axis, here 1 by, in graph B, 1 by V0 representing the x-axis, right? So graph B is wrong. So the graph A is correct, right? Graph A is correct. What is the slope? The slope will be f0 divided by V minus Vs, right? f0 divided by V minus Vs. So the correct option is here C, right? f0 divided by V minus Vs. Yeah. Next question, question number 48. In which mode of transmission the heat waves travel along straight line with the speed of light? The direct question, right? Thermal radiation, right? In thermal radiation, that is radiation mode of the transmission, right? Transmission mode is thermal radiation. The heat waves travels along the straight line with the speed of light. So the correct option is A. Next question, question number 49. The escape velocity of the projectile in the Earth's surface is 11.2 km per second. A body is projected out with the thrice this speed. The speed of the body far away from the Earth will be. Okay, far away from the Earth. That is, from the center of the Earth to the position of the object is almost infinity. Okay, after the projection. Yeah. So this is the Earth. Okay. From the surface of the Earth, the particle is projected. Okay. The velocity of the projectile is 3 times velocity of the escape velocity. Okay. So object is somewhere here. Okay. So at this point the gravitational potential energy is 0, right? And then we need to find what we need to find, the speed of the body far away from the Earth, right? That is, we need to find the velocity of the or speed of the body at infinity. Okay, speed of the body at infinity. Apply conservation of energy, right? Here, according to the conservation of energy, total energy, right? Initial total energy equal to final total energy. Initial total energy is gravitational potential energy, that is minus G mm divided by R. So capital M is mass of the Earth, okay, small m is mass of the projectile, plus half m into v dash square. So this is v dash, okay, equal to half m into v square plus 0. 0 is gravitational potential energy at infinity, that is 0 because R equal to infinity, right? Yeah. So now here minus Gm m divided by R, right? Minus Gmm divided by R plus half m into 3 times Ve square equal to half m into 3 times Ve whole square equal to half mv square equal to plus 0. We know that escape velocity Ve equal to root of 2gm divided by R, right? So now gm divided by R is equal to Ve square divided by 2, right? Ve square divided by 2. So now I can write this expression as minus gm by R as minus V square by 2, right? So this will be minus mv square divided by 2, minus mv square divided by 2 plus 9mv square divided by 2 equal to half m v square. So half will get cancelled, right? And then m will get cancelled. So this will be 8 mv square, okay? 8 mv square, mve square is equal to v square. So now v equal to m anyway got cancelled, right? So v equal to 2 root 2 ve. So v equal to 2 into root 2 into ve, right? 2 into root 2 is almost 3, right? Isn't it? 2 into root 2 is 1.4, almost equal to 3, right? So v is approximately equal to here 33.6 kilometer per hour, okay? 33.6 kilometer per second, not hour, per second. So the correct option is C. Okay, yeah. Next one, question number 50. Consider a compound slab consisting of 2 different materials having equal lengths, thickness and thermal conductivities K, 2K respectively. The equivalent thermal conductivity of the slab is. Okay, so here the equivalent thermal conductivity of the compound slab, right? So K equivalent is equal to L1 plus L2 divided by L1 divided by K1 plus L2 divided by K2. Okay, so the materials are different, right? So two different materials having equal lengths, that is L1 equal to L2, which is equal to L. Okay, so K equivalent is equal to 2L divided by L divided by K plus L divided by 2K. So anyway, L will get cancelled, right? So K equivalent is equal to 2 divided by, so take 1 by K as common, then 1 plus 1 by 2 is 3 by 2. So 3 by 2K. 3 by 2K. So then here K equivalent is equal to 4 divided by 3K. This is the K equivalent. So the correct option is C. Next one, question number 51. A circular coil of 20 turns and radius 10 cm is placed in a uniform magnetic field of 0.1 Tesla, normal to the plane of the circular coil If the current in the coil is 5 ampere, then the average force on the electron in the coil due to the magnetic field is given. Cross-sectional area of the wire is 10 to the power minus 5 meter square and free electron density is 10 to the power 29 per meter cube. Okay, so we know that average force or the force exerting on the electron due to magnetic field is E into V into B. V is drift velocity of the electron. Okay, so we know that the current I equal to NEA V, right? V is drift velocity of the electron, A is area of cross section of the wire, E is charge of the electron, N is area of free electron density, right? So here EV is equal to I divided by N into A, right? So now substitute EV, expression of EV to the first equation. So now F is equal to IB divided by N into A. So now F equal to I is 5 ampere, B is 0.1 Tesla, that is 10 to the power minus 1 divided by N is 10 to the power 29, A is 10 to the power minus 5. So this is 10 to the power minus 24. Okay, sorry, 10 to the power 24, right? 10 to the power 24 into, so then take 1 by 10, take 10 to the power 24 to the numerator, then 10 to the power minus 24, 10 to the power minus 24 into 10 to the power minus 1 is 10 to the power minus 25. So F equal to 5 into 10 to the power minus 25 Newton. So this is the average force exerted on the electron. So the correct option is C. Next question, question number 52. With what minimum acceleration can fireman slide down the rope while breaking strength of the rope is 2 by 3 of the weight. 2 by 3 of his weight. Okay. So he is sliding down, right? This is the rope. Okay. So the fireman is sliding down with the acceleration A. So we need to find A, right? So mass of the fireman is M, then the force due to gravity acting on the man is mg, right? So now apply Newton's second law of motion, right? So here mg minus t is the tension in the slope, okay? Mg minus t equal to m into A, right? Mg minus m equal to, mg minus t equal to m into A. T is the tension in the string, okay? Maximum tension in the string is 2 by 3 of his weight, right? So mg minus 2 by 3 times mg is equal to ma, right? So now m will get cancelled. So then 3g minus 2g is g. So A equal to g by 3. So the correct option is C. Okay. Yeah. Next question, question number 53. The string of length 2 meter is fixed at both ends. Okay. Fixed at both ends, right? If the string vibrates in its fourth normal mode with the frequency of 500 Hz, then waves would travel on with the velocity of. Your string is fixed at both ends, right? So then here the frequency of the wave will be f equal to nv divided by 2l. V is the velocity of the wave, right? L is length of the string, n is the number of modes, right? So n equal to 4, right? Fourth normal mode. So f equal to 500 Hz. So 500 is equal to 4 V divided by 2 into 2, that is 4. So 4 will get cancelled, right? So V equal to 500 meter per second. So the correct option is C. Next question, question number 54. An alternating voltage 200 sine of 100t is applied to a series combination of R equal to 30 ohm and an inductor 400 milliohm. The power factor of the circuit is, so power factor cos phi is equal to R by Z, right? Power factor cos phi is equal to R by Z, right? So cos phi is equal to R, that is 30 ohm, divided by Z is R square plus XL square, right? R square, that is 30 squared plus XL square, right? So XL is omega into L. Omega is 100, right? 100 radian per second, right? L is 400 millihenry. So omega, that is 100 into 400 into 10 to the power minus 3 squared. Okay. So now this will be 40, right? So cos phi is equal to 30 divided by root of 30 square plus 40 square, right? So take 10 square as common here. So 3 square plus 4 square, right? So this will be 25. Root of 25 is 5. Root of 10 square is 10. So now cos phi is equal to 30 divided by 50. So 0, 0, that is 10, 10 will get cancelled. Cos phi is equal to 3 by 5. That is 0.6. So the correct option is B. Okay, this is the power factor. Next question, question number 55. In the network shown in figure, the equivalent capacitance between points P and Q. Okay, so here let us find equivalent capacitance between B and E, okay, and then A and F, okay, then P and Q. Why? Because these three are in series, then parallel with 2 microfarad. Again these three are in series, right? So then parallel with 2 microfarad. Again these three are in series, right? Okay. So now what is the capacitance, equivalent capacitance between B and E, right? Point B and E here. Okay, B and E, right? Equivalent capacitance between B and E. So now 3 microfarad, 3 microfarad, 3 microfarad. These three are in series, right? So now what is the equivalent capacitance? 1 microfarad, right? 1 by 3 plus 1 by 3 plus 1 by 3. So that will be 3 by 3, that is 1. So 1 microfarad. So then 1 microfarad is in parallel with 2 microfarad, right? So equivalent capacitance between B and E is 3 microfarad. 2 plus 1 is 3. So 3 microfarad, right? So now equivalent capacitance between A and F. Okay, equivalent capacitance between A and F. So now again 3 microfarad. Here this is 3 microfarad, 3 microfarad. All these three are in series, right? So equivalent capacitance is 1, right? So then 1 microfarad is in series with, parallel with 2 microfarad. Again equivalent capacitance between A and F is 3 microfarad. So now equivalent capacitance between P and Q, right? So now this is the 3 microfarad, right? 3 microfarad. So now again these 3 microfarad capacitors are in series, right? Isn't it? So therefore equivalent capacitance between P and Q is 1 microfarad. So the correct option is A. Okay. Yeah. Next question, question number 56. The resultant of two forces acting at an angle of 120 degree is 10 kg weight and is perpendicular to the one of the forces. That force is, okay, so this is the resultant force F1 and F2 perpendicular to the one of the force, right? Angle between them is 120 degree. Okay, angle between them is 120 degree. So now this is the another force F2. This is F1. Okay, so here we need to find F2, right? Okay, so what is this angle? This angle will be 30 degree, right? The angle is 30 degree. So now here tan 30 degree is equal to So the force here, the resultant force, right, tan 30 degrees equal to perpendicular by base, right? So perpendicular by base. So let's say this perpendicular is x divided by base, right? X divided by base, that is 10 kg weight. So now x equal to tan 30 degrees 1 by root 3. So 10 divided by root 3 kg W, right? So the correct option is A. Next question, question number 57. Choose the incorrect statements. Silicon is used fabrication of LED. So here we need to find the correct statement, right? Silicon is used in the fabrication of LED. Yeah, correct, right? LED is light emitting diode. Here we used silicon in the fabrication of LED. Yeah, correct. LED works in the principle of electroluminescence. Wrong. Option C says LED is a power of efficient device. No, this one is, sorry, this statement is wrong, right? Question number 57. Choose the incorrect statement. Remember, we have to choose incorrect statement. Option A says silicon is used in the fabrication of LED. Wrong. Silicon is not used in the fabrication of LED, right? So we use gallium arsenide, right? Gallium arsenide in the fabrication of LED, right? Option A is wrong. Option B, sorry, statement in the option A is wrong. So option A is correct. This is the incorrect statement. Option B, LED works on the principle of electroluminescence. Correct. Option C says power of efficient device. Yeah, statement in the C is also correct. Option D says LED fabricated with the direct band gap semiconductor. This one is also correct. So the correct option is A. Okay. Statement in the option A is wrong. So correct option is A. Question number 58. Charge on electron is simple one, right? Minus 1.6 into 10 to the power minus 19 coulomb. Question number 59. Two charged spheres of minus 20 microcoulomb and 60 microcoulomb are kept at a certain distance. They are touched and kept again at the same distance. What is the ratio of force experienced before and after? Okay, so now two charged spheres, right? So minus 20 microcoulomb, 60 microcoulomb, right? Separated by a certain distance r. So now force between them F equal to 1 divided by 4 pi epsilon naught Q1, that is 60 square into Q2, magnitude of the Q2, okay, 20 square into 10 to the power minus 12 into 10 to the power minus 12, 10 to the power minus 6 into 10 to the power minus 6 is 10 to the power minus 12 divided by r square. Okay, yeah. So now these two spheres are touched, right? So now charge distribution will take place. So now what is the final charge on each sphere? So Q equal to Q1 plus Q2 by 2, right? So that will be 60 minus 20 divided by 2. So Q equal to, so this will be 20 microfarad, right? So after touching the two spheres, what happens? Charge distribution will take place. So now the charge on each sphere will be 20 microfarad, right? Okay. So now again, these two are separated by distance r. So now the new force F dash is equal to 1 divided by 4 pi epsilon naught into Q square, that is 20 squared into 10 to the power minus 12 divided by r square. So now we need to find ratio of the force experience before and after. Okay, ratio of force experience before and after. So that is F divided by F dash is equal to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught will get cancelled. 1 by r square will also get cancelled. And 10 to the power minus 12, 10 to the power minus 12 will also get cancelled, right? So now here, sorry, this is 60 into 20, okay, not 60 square into 20 square, 60 into 20, okay. So now here 60 into 20 divided by 20 squared. So now 20 will get cancelled, 23s are 60. So now F divided by F dash is equal to 3 by 1, that is 3:1. So the correct option is B. Next question, question number 60. And the last one. The AC voltage across resistance can be measured using a. Okay. AC voltage across a resistance can be measured using a moving coil galvanometer. Okay. Simple one. Moving coil galvanometer. Moving coil galvanometer, right? So why? Because here we connect a external resistance R in series with the moving coil galvanometer, right? So then moving coil galvanometer acts like a voltmeter, isn't it? And then if you pass the current, sorry, if you connect, right, moving coil galvanometer as a voltmeter, then it will show the deflection, right? So the correct option is B. So thank you so much for watching this video. If you love this video, please like and share. And if you want to watch more such videos, please subscribe. Thank you.